Bene, allora penso che possiamo cominciare. Good afternoon. Welcome to our guest, Mr. Steve Thompson, Senior Vice President of Distributors, Mr. Gary Goodhart, CEO of Intuitive, and Mr. John van der Horst, which is the Director of Italy and Iberia, Intuitive. I'm very proud to host you here in this historical building. This is the heart of our university, I would say. So I'm glad we eventually managed to be back in presence after 2 very difficult years. And well, this is the first event which I attend, which is, fully booked in this room. This means that there is a great interest of our university, and not only. Let me welcome also the Mayor of Pisa, Mr. Michele Conti. Thank you very much, Michele, for being here. And the President of the Regional Council, Antonio Mazzeo. Thank you, Antonio. And you already met Ms. Briani, Ms. Lucchini, and Mr. Milli this morning in the meeting in our university hospital. So let me start with no words, but a short video that introduce to our guest our university. Okay. Back. So it's always impressive to see this video. Actually, some numbers must be updated because we have more than 130 degrees, but the numbers are always impressive. Clearly, I cannot go through such a long history in these few minutes that I'm given. And since our meeting is about next generation surgery, with contribution, of course, from ICT and technologies and robotics, let me, in these few minutes, zoom on these scientific fields. You have already discussed this morning in the meeting at the University Hospital about medical and life science, and let me focus on these two fields, ICT and robotics. ICT has witnessed several pioneering contributions by University of Pisa since the middle of the last century. In 1954, the Nobel Prize Enrico Fermi wrote to the director Enrico Vanzi, suggesting to support the construction of a computer for scientific calculus. Here is the letter that Enrico Fermi, that you can see in the picture, wrote to Director Enrico Vanzi, and he was mentioning a computer for scientific calculus which should be fast and precise. Okay, and you can see. Well, actually, the computer was built thanks to a generous budget given by the provinces of Lucca, Livorno, and Pisa. Here you can see a picture of the Calcolatrice Elettronica Pisana, the CEP, as it is called, which was inaugurated in 1961. After 6 years, the project lasted for 6 years, since 1955 to 1961. You can see a picture of the CEP. Now is in our Museum of Scientific Calculus, in one of the 11 museums that you have seen in the video. CEP occupied the whole room, and the computing power of CEP was, of course, much smaller of the one available on our commodity smartphones that we use today. But that was the first step. And after that, from Pisa started the first ping in 1986. A group of researchers of Pisa, coordinated by our colleague Luciano Lenzini, coordinated this group. They originated the first ping in Pisa. It was done by the CNUCE, the University Center for Electronic Calculus of the National Research Council. The ping was sent from Pisa to Roaring Creek in Pennsylvania, and that was the first. The second step. Here is the. Oops, sorry. Here is a picture of CNUCE when it was inaugurated in 1965. And then from then on, the history of ICT and the robotics in Pisa is disseminated, I would say, of milestones. Researchers in Pisa, of the University of Pisa and the other institutes, continue to innovate. Here is a list of a short list of the main results that I have selected with the goal of highlighting our continuous attention to innovate education and to grow next generation researchers and professionals in the technology setting with a multidisciplinary eyes, as well as creating opportunities for matching research results with industrial needs. You can see in the come si fa a puntare qui? Well, in the in the corner box, this project by the Information Engineer Department, which is a cross-lab, the cross-lab project, which is exactly this hope to match research result with industrial applications. University of Pisa, together with the other institutions in our small city, but scientifically very big. I mentioned here the Scuola Superiore Sant'Anna. You have seen it in the video. The Scuola Normale Superiore as well, and the National Research Council, which are all located in Pisa. Also with many other institutes, research institute. Together with them, the whole, let's say, Pisa research system not only offers opportunities for education, from bachelor's to PhD to master programs and postdocs, we offer also key research innovation opportunities for the next generation surgery. And in order to sustain this statement, let me comment on the pipeline of modern science and how our university has invested and is currently investing to implement this. And these are the five ingredients that you can see. Let me go through each of them quickly. First of all, advanced instruments. We need the availability of sophisticated instruments for performing advanced research. And in this line, we have launched in 2018 the Center for Instrument Sharing, which is called CISUP. CISUP is a laboratory platform offering free access to a wide range of analytical instruments for life and physical sciences. You can see a list, not complete list, here in the left. It gathers now nearly 500 researchers. They come from 18 departments. We have 20 departments overall, so nearly all the university, and 9 specialized labs. In the last year, CISUP has experienced 12,000 hours per year of instrument sharing, which is, I believe, an incredible figure of how good was the choice of launching these initiatives. In the last four years, we invested 13 million euros in CISUP, both from our internal budget and from Stella grants. And we hope that this 13 million could become 18 million very soon from the grants of Italian National Resilience and Recovery Plan from Next Generation EU. CISUP is involved in many initiatives in this plan. The second ingredient, data production and communication. We talked about this quickly also this morning. University of Pisa is a proprietary network, so it's our network of the university, of about 90 kilometers of tubes, which are spread all over the city. You can see, well, you can not see, but just have a look on this map. All these lines are the network. The networks, the cables connect 250 buildings all over the town, and not only, including the hospital, the University Hospital you have seen this morning, and of course the future Theatre Institute we have talked about, and we will mention also later on. The speed of the connection is about 200 gigabytes per second, and they form a GAR network. GAR is the National Network for Education and Research. Our network is a node of the GAR. So this is very important. This is a very important point. The third ingredient, high-performance computing and storage for data analysis, simulation, visualization, control, automation, etc. We have four data centers in our university, but one of them deserves a special mention. Is the so-called Green Data Center. You can see a picture of it. It is the largest. It has been built in the beautiful area of San Piero Grado in the Sarosore Park. But it's green not only because it's located there, it's green because it has been built according to the latest technology in terms of energy saving. It nowadays achieves a power usage effectiveness less than 1.2. The average of PEU of the green data center spread all over the world is 1.8, so it's a very good record. It has 20,000 cores and 100 GPUs, 300 terabytes of RAM, 12 petabytes of storage, so it's a very big data center. The security of the data center is based on the zero trust architecture, based on the principle never trust, always verify, so very secure. And is a competence center. Our Green Data Center is a competence center for Dell Technologies, Intel, Microsoft, NVIDIA, SonicWall, VMware. So it has been recognized as an excellence center by these companies. Last but not least, our Green Data Center was awarded the Class A, so the top rank class, by the National Agency for Digital Italy, AGID, selected from 1,100 nearly public data centers and within the top 62. And this is another important achievement of we are very proud of. Fourth ingredient, we have talked about technological ingredients up to now. The fourth ingredient is a human ingredient, let's say. So knowledge and competencies. We have in the last 10 years, UNIP was involved in nearly 240 projects funded by the European Commission, and 59 as the coordinator, principal investigator. Most of them, as you can see, are in ICT and life science, 169, for a total budget of about 1.2 billion euros, and 61.4 million euros of this were for UNIP. We are hosting 11 ERC grants, and 6 of them are in ICT and life sciences. So in the topics related to what we're talking about today. This is just a short list, only the one that are funded by European Commission. Then we have many other projects, national and also international other projects. Our researchers are now putting a significant effort towards the initiatives of the Italian Recovery and Resilience Plan, the so-called PNRR. In particular, we are involved in projects in crossing life science, AI, robotics, big data, and HPC. In these projects, networks, we are playing a key role, a key national role. Oops. Okay. Fourth ingredient, knowledge and competencies. We strongly believe that the quality of research is strictly tied to the quality of networking opportunities we established in the last years with prestigious research centers all over the world. We have more than 300 inter-university agreements worldwide. I just mentioned 3 of them here. One is with Massachusetts, with MIT, is an agreement signed in 2012. It has financed more than 60 projects involving many scientific areas, but of course most in ICT and life sciences. We are involved in the SPARK project with Stanford University since 2018. SPARK is a worldwide partnership between universities and the industries to, I quote, accelerate discoveries from laboratories to patients, particularly in the field of biomedical and pharmaceutical and pharmacological areas. Last, I would like to mention is the agreement with Fermilab in Chicago, in which we are contributing to build the USA quantum computer in collaboration with Anna Grassellino, who was a student of University of Pisa, and her SQMS center. We have a very long history of multi and interdisciplinary research projects and teaching initiatives between life science and ICT and beyond. Just to mention a few, I mentioned the Multi-Departmental Research Center, PROSIT. PROSIT stands for Promotion of Health and of Healthcare and Information Technology. This involves tens of researchers spread over many departments of our university, including also Department of Humanities and laws, not only technological and scientific department. And PROSIT deals with projects crossing of health and technology. We have many interdisciplinary education initiatives at the master and PhD levels. Let me just mention the last one, which is a master degree in collaboration with University of Stockholm, Marseille, and Barcelona on biotechnologies and applied artificial intelligence for health. And this is a master that will start this year. Modern science, we know, is intrinsically inter and multidisciplinary, and we try to be at the highest possible level in this, not only from a technological or medical, let's say, point of view, but also in terms of ethical and privacy issues, and this is why we teach these topics starting from the very first degrees in the STEM bachelor courses. Finally, the last ingredient, innovation and social impact. You have seen this morning the project of the Theater Institute, which is we have to thank Professor Melfi for this. The mission of theater, as you see, is to offer training courses to physicians, to surgeons, to students, to postdocs, to PhDs, but also to residents and STEM professionals, as we mentioned this morning. Theater will issue a higher education certificate recognized at the university level by the University of Pisa, but the most important hope and dream is that theater will become an innovation hub, including all disciplines in the design and development of ICT devices, materials, AI, and robotics tools for the medical sector. But also theater playing as a hub will contribute also to produce data, produce precious data that need to be analyzed, need to be distributed and analyzed, and this is, in a sense, the closing of the virtuous cycle of these 5 ingredients I've mentioned in these slides. Finally, a personal hope. The hope is that the Pisa research system as a whole will not only continue to collaborate for for running projects, impactful projects that we have seen, and growing up excellent researchers and innovators, as we did in the last year. I can say surely that our students and researchers have contributed significantly to worldwide innovation, often in forms that we are not able to track exactly or miss. So we must definitely improve in the valorization of our alumni and researchers. This is why in this slide I show you a recent unicorn which was born in the USA and funded by two master students of University of Pisa, Alessio Signorini, the first one, and Luca Foschini. And this is exactly in the area of AI tools for processing health data. These two guys did a great job. And I think also this witnesses the goodness of our education system, actually of the Pisa education system. Lorenzo was a student of University of Pisa and a student of Scuola Sant'Anna Superiore also. Well, but you know, my hope is that centers like the theater one that we are about to start, and the other centers that hopefully will be built with the support of the National Research Plan, will allow us to attract these younger researchers back to Pisa, possibly after a period in the abroad. We know how important it is to spend time in the research institute and foreign research institutes, as these guys did. But we hope that we can attract them back to Pisa, to their country, to help the country innovate and progress. This is it. I thank you for your attention, and I think I have to give back.
Thank you. No, I don't have a slide. Thank you for this amazing speech. Thank you to all, to everybody. Thank you to the guests. And now we are moving the first. I have, yes? Okay. Maybe I haven't used that. So we are moving to the first speaker. He doesn't have any necessity to introduce with the biography, but I believe that is very important to describe his biography. So I summarized some key points of his biography. The first speaker will be Professor Pedreschi. He is a professor of computer science at the University of Pisa and a pioneering scientist in data science and artificial intelligence. He is currently shaping the research frontier of human-centered artificial intelligence, as a leading figure in the European network of research laboratories called Human AI Net. He is also a founder of the European Research Infrastructure Data, dealing with big data, analytics, and social mining ecosystem, and involving more than 30 European partners. Professor Pedreschi is currently, among other things, the Italian member of the responsible of AI working group of GPAI, the Global Partnership on AI. He is a member of the OECD network of experts in AI a member of the panel of the Council of Europe for the application of AI in law. And again, he is the coordinator of the working group Big Data and AI for Policy established by the Italian government as a data-driven task force during the pandemic emergency. In May 2020, Professor Pedreschi has been requested by the European Parliament to write an independent study on the impact of AI on online platforms and marketplaces, and he is the director of the Data Science PhD program at Scuola Normale Superiore in Pisa, and recently on the National PhD program in Artificial Intelligence for the University of Pisa and the CNR, is a National Research Center. So it's just a summary. Thank you for all this work, and I would like to ask you to start with your presentation.
Yes, can you hear me? So first of all, thank you very much, Franca. This is for this fantastic introduction, not deserved at all, but very much. I'm very happy to be here this afternoon to give a contribution that, of course, is not directly on surgery, which is not my field of expertise. As Franca said, my field of expertise is data science and artificial intelligence, and I believe that this is also part of the picture, and I will try to very quickly have a glimpse at how we might help along this road. Having, as Rector Maccarella has already said, having a long history in data science and artificial intelligence that can be today is able to put us into this focus of human-centered artificial intelligence, where we actually are developing as an international hub. I would like to quickly give first a scientific idea of what are our area of expertise and work, and then focus on the more institutional part of what kind of projects and what kind of relationships we built and what critical mass we have in our ecosystem. The point is, very quickly, is that we have witnessed an incredible, let's say, recent progress by artificial intelligence in problems that have been open till the time of Alan Turing, like recognizing what is the content on image, understanding a text, translating automatically a text. Very much impressive. But at the same time, we witness that in certain critical area where the risk of the application is not as low as translating a text, no, but it's deciding about the life of a patient, or deciding about people in tribunal making an issue, then in these aspects, the adoption of AI is still lagging behind. It's not as, let's say, it's not matching our expectations. We can do better. What are the main adoption barriers? Many, but one very big barrier is lack of trust. The fact that users, different kind of users, from stray-men to doctors to lawyers, don't really understand, are not sufficiently engaged in understanding the assumptions, the limitations, and the capabilities of AI systems today. We can do better. We need actually AI that is not yet there. We need very good fundamental empirical research in AI, well beyond current technologies, because we need systems that are able to co-evolve with humans, interact with us, and learn synergistically interacting with people by leveraging on the strengths and weaknesses that humans and machines have. we need tools that allow us to make better decisions, so enhance our ability of make decisions, systems that are able to perceive, act, evolve, adapt to changing environments, systems that are aware of their limitation, what they don't know, what they can't do, so that can guide appropriately the interaction with users. Systems that are aware also of the parameters of their security and trust. What they're essentially able to ensure in terms of safety and security. And of course, we need systems that are built with the idea of understanding their environmental, social impact better than what we have today. That's the main ideas, around human-centered AI. Shaping this AI revolution, we are in a direction that is beneficial to people, both as individuals and as a society, at different levels of a society, from communities to the global society. And this is the logo of the Human AI network that we are leading from the Italian side for a part of it. It's a big, especially EU-based community of scientists that are trying to understand, somehow to focus on these topics, systems that understand human objectives, that are able to interact in complex social settings, that are essentially able to empower people rather than replace or manipulate people, respecting human autonomy and agency and ability of self-determinate. I would like to just give a glimpse of this idea with, of course, scientists are always in love with the latest production. So let me just give a glimpse of a result from just presented days ago at the main conference on, not in AI, but in human-computer interaction. And it's about trying to understand to what extent different kind of tools, AI tools, can somehow give more or less trust to physicians that are trying to make a clinical decision. And here the point is essentially a doctor that, based on the clinical history of a patient, is trying to understand what is the risk of an acute myocardic infarction in the next few months, okay? Will this clinical history be predictive of a serious risk of infarction? And the question is, what happens if we administrate like a therapy, let's say, to the doctor, an AI tool as a support to this decisional problem? Essentially, will this improve the confidence of the doctor in the decision? What kind of relation will the doctor have with the AI tool? There is a very interesting, let's say, conundrum here to evaluate, right? That is related to trust. It's related to explainable AIs, in conversational systems that are try to not only to predict or to make, let's say, suggestions or recommendations, but also trying to explain the reason why they arrived to certain recommendation. It's a territory that is terribly, let's say, complex. We always somehow risk to go towards over-reliance, just let the algorithm make the decision, or on the other opposite, aversion. Now, I simply don't trust this and I don't use it, don't adopt it. What is and this, in my opinion, is one of the biggest challenge today for AI, and a challenge that must be taken with the proper mix of competencies. It's not only for computer scientists. We need to team up, for instance, with cognitive scientists and psychologists, and of course, with physicians. I just want to very quickly tell you what is the experiment here. In trying to understand what are the chances that a patient will have an acute myocardial infarction in the near future, we consider two possible different of system. One that is a black box, is an AI predictor that does not provide an explanation, and the other one instead is a explainable AI system, a system that tries with some level of interface to produce an explanation. And we set up a kind of randomized control trial, the equivalence of a random, or on a small scale, of course, because it's very difficult to put together this kind of thing, to understand whether it is possible to assess a different variation of trust in the two cases. And what are the key points? Three take-home messages. First, healthcare professionals trust more, in a statistical significant way, they trust more the suggestion with the explanation compared with without. The explanation provided did not satisfy the doctors. They found it was terribly bad, which is also very interesting information to have. And also we saw that in many professionals there was some perception of AI as a replacement rather than a decisional support. This is very precious information to have, because this make us understand that we are hacking with this kind of tools the decisional process, the cognitive process of humans, of human experts. We need to understand the social-cultural environment for that. We need to co-design this kind of system together with all the stakeholders in a strongly interdisciplinary way, because we need not simply to design the AI system. We need to design the decisional process as a whole, together with the human experts. In our ERC project on explainable AI, we like to use the Dr. House model to somehow illustrate what would like to go to. No? Dr. House is a team of people that tries to address very complicated clinical cases, and the people around us, well, it doesn't really have, let's say, helpers that never fail, okay? An AI tool that it's always, or let's say 98% correct, is not necessarily a help for Dr. House. A better help is perhaps a colleague that makes an hypothesis on explaining why. This hypothesis may be revealed false, but it's a fantastic push for getting all together in collaboration to the final, to solving a very complex problem. So the point here is how we are able to design synergistic human-AI collaboration. We can imagine that this team is made partly by doctors and partly by AI systems that help in the end the team make better decision, while actually not only preserving but even expanding the human agency and the human autonomy in the project, in the process. So this is an example. I chose this example because I think it's intuitive. It's intuitively matching a need that we all perceive as pressing. There are many other lines. The message is that Pisa today is an international hub for this kind of research. Of course, not alone, but together, has been already mentioned various times, the other School of Excellence that we have, the National Research Council. We have a centrality in cutting-edge research. It's not only ERC project, it's not only the research network of excellence in AI in Europe. We belong to all of them. We also have, together with our colleagues in the ecosystem, we have a large infrastructure for big data analytics that is helping all this ecosystem to grow. We have several Marie Curie schools that are very useful because they attract excellent PhD students from anywhere, basically, and we have a long list of, let's say, cutting-edge European projects on these topics. Many connections with industry. In all these lines, telecom companies, big web or big or small web providers, insurance, banking, public administration, retail, mobility. We have lots of activity in industrial project with many startups also working, and these are especially in the area, it's general of healthcare, personal healthcare system and well-being. We have lines that are span all the dimension. I just mentioned one dimension of human-centered AI, which is explainability and human-AI collaboration, but there is also this very fascinating new wave of machine learning that bridge across system 1 and system 2. No? The intuitive part of our brain and the rational part of our brain. Machine learning that somehow cross between system 1 and system 2 is actually in two senses. One is that the machine learning model is able to reconcile, let's say, intuition with rationality. But on the other hand, it's also possible that the machine learning model talks to the system 1 and system 2 of the human users. And I don't go through the list here. I only mentioned that healthcare and precision medicine are the key driver domains for pursuing this kind of research. I conclude by simply saying on these topics we have a critical mass of researchers, more than 100 research staff working in this, a huge number of early stage researchers and postdocs. And we are, and this is the message, we are producing talents all the time. We are producing AI talents. Everybody knows that talents in AI and big data are very precious and scarce resource. We are able with our courses to, and the fact that we have two different departments and a lot of relation with all the other people in the ecosystem, we have a lot of ways of somehow fostering AI and data science talent. Was already remembering in this area that we have in 2002, so 20 years back, we started the first Italian, I would say the first European degree, Master of Science degree in data science, then the first postgraduate master in big data analytics, the first PhD program in data science, one of the earliest master degree in artificial intelligence and data engineering, and recently we are leading the Italian national program for a PhD program for artificial intelligence, which is something that it's started last year. We are creating more than 40 people every year only in Pisa, and almost 150 overall in Italy, trying to really have a kind of shock therapy for introducing new talents. And we have a focus on AI for society in Pisa, but the network is actually very well spread across Italy. So this is basically what I wanted to say. The final, very, very final message, we are also connecting with Florence and with our networks in Florence and Siena. We have a Tuscan hub which is organized. Florence and Siena also have very interesting competencies in artificial intelligence and data science, and this kind of network is also a way to expand the strength of our ecosystem. Thank you very much.
Thank you. Thank you for this really interesting lecture. Now we are moving in next speaker. We have two speakers who are in the US, both. they are in Philadelphia because they are involved in the ICRA conference, the International Conference on Robotics and Automation. The first speaker will be Antonio Bicchi. Professor Bicchi is a chair of robotics at University of Pisa and senior scientist at Italian Institute of Technology in Genoa. In 2009, he founded the Soft Robotics Laboratory at Italian Institute of Genova of Technology in Genoa. And since 2013, he is an adjunct professor at Arizona State University in Tempe. He has coordinated several international projects, including a project from the European Research Council on haptics, collaborative robotics, soft robotics, artificial robot hands, and prostheses. He served the research community in several ways, including the launch of the World Haptics Conference and the IEE Robotics and Automation Letters. Professor Bicchi, he is also a fellow of IEE since 2005 and received the IEEE Seridis Leadership Award in 2010. He is a co-founder and currently the president of Italian Institute of Robotics and Intelligent Machine, IRIM, since 2019. I hope that we are connected. Hello?
Hello, hello.
Thank you.
Okay, thank you very much. I have a echo back. I hope you don't. Can I take my echo out? Well, let me try and start while the technical stuff will take this echo off, I hope. Thank you very much for introducing me. I apologize for not being able to be with you in person today. Can we have the slides? I think Professor Bianchi will help me with this talk. I don't see. I only see my face here.
We don't see you either.
Of course, we tried.
They're projecting the slides, Antonio.
Okay. I don't see the slides though. Can I try and share slides from? Oh, here they are. Oh, no. Okay, great.
Okay.
Sorry, this is the annual conference for robotics. It's the first time we are here for 4,500 people in presence. It's great to be here again. I couldn't miss it. So I apologize with you for being here. So why robotics in Italy and Pisa, who we are, where we come from. As mentioned, the robotics community in Italy is vibrant, strong, and it has been collected in Italian Institute of Robotics and Machines, who not casually has its place, its headquarters here in Pisa. And we have collected data. So, for instance, if you think of robotics, then the major powerhouse of robotics research in worldwide is the European Union, and Italy is strong in terms of publications, in terms of absolute numbers, but also in terms of quality. Actually, in terms of specific weight of the work we do, Italian robotics is number 1 or number 2, depending on the metrics that you use. So we're proud of this result. And in specific terms, surgical robotics in Italy is also very strong. We have strong groups in Milan, in Verona, in Genova, in Rome, in Naples. But if you look at Pisa, then you find that there is a direct delta of competencies. There are groups, Ariana Paolo Dario, Sant'Anna, our group in Pisa, and of course the strong collaboration with excellent surgeons, Umberto Boggi and Franca Melfi, of course, and many others that I cannot mention here. So we recently got almost through. It's not finalized yet, so I should wait a minute. But With this PNRR, we created a hub for the Tuscan health environment, where we hope that there will be a spoke of robotics and automation for health, 14 millions, just for this purpose, where the Pisa, Sant'Anna, Florence, and Siena universities will collaborate in building what we hope will be future surgery with AI and robotics. Yes. Next, please. So Pisa, why Pisa is so strong in robotics? Well, first of all, you might have seen this is a paper published on the Journal of Endourology about the Davinci robot, but sorry for our guest here, it is not from Intuitive Surgical. It was the original design by Leonardo da Vinci. Vinci is a city that is only 50, 60 kilometers from Pisa. So our roots go back very deep and very far, but there are other reasons. The one that Pisa is also very strong in medicine and life sciences, and we know how to bridge the technical and the life sciences through the methods that Galileo has posed at the basis of science. That is mathematics as the language that can match nature, very different natural bodies, embodiments. More recently, Pisa is also very strong in robotics. And one of the things that Pisa has pioneered with several groups is soft robotics, robots that use soft materials or soft actuation principles to comply and better behave with humans. Next, please. So one of the things that we try to do here is make robots with people in mind. Next, please. And a specific action that has been always at the center of attention here in the research in Pisa is artificial hands. So artificial hands have a very long history. And in Pisa, we have had bionic hands that of different types. Several of those made at the Scuola Sant'Anna. For instance, here we have some that maybe Ariana will show later. Next, please. But when you look at the problem of doing artificial hands, you realize that the human hand is a very complex system that is used very simply by humans. If you compare with existing, one back, please. If you compare with existing prosthesis, no prosthesis can match the complexity of the human arm. Still, prostheses are much more complex to use than normal hands. Why is that? Because there is some intelligence in the use of hands that is beyond the mere computational or the mere mechanistic intelligence. So we have been working with neuroscientists to understand the basis of the organization of the hand control in the brain. And through these studies, we have understood that there are modes or synergies that are fundamental in the use of hands. Through this, next please. Through this, we have built hands that have, first of all, they're soft and they're very simple to control, but they're as articulated as a real human hand with 19 degrees of freedom and the wrist, even a pliable palm. Now, the processes that we have developed are being used in many universities worldwide. And today there is an NIH R01 project that uses these hands with 20 patients that are evaluating those processes at their home for 2 months each. You see many other with Mayo Clinic and Arizona State University. In another project that we are doing at the intersection between medicine, life sciences, and engineering, is this natural bionics project where a surgeon, Professor Assmann from Vienna, and a neuroengineer, Professor Farina from Imperial College, will work with us to build robots that really naturally integrate with the human parts. Next, please. So the surgeon will do is doing targeted muscular reinnervation to bring neural terminations on the stump from the nerves that used to go to the hand. Next, please. And these will be used for both efferent and afferent reinnervation, so that our processes will talk directly to the spine of the patient, and therefore there will be naturally integrated in the natural motor scheme of the patient. So this is really frontier research that we're trying to do. Note that is not only the command of the prosthesis, but it will also be the feedback, the tactile feedback that goes back from the hand. And probably everybody realizes how important is this feedback. If you count the nervous fibers that go through the nerves in the arm to the hand, there are some 350,000 nerve fibers, and only 10% of these are actuating the arm. The 90% of these are bringing feedback back to the person. So reinnervating those fibers is very important, and providing technical measurements to this feedback system is our goal. Please, next. Some of this work has been implemented in practical devices that even participated in competitions. Here is the Cybathlon, that is a rather famous competition organized by ETH at Olympics, sort of like Formula One with high technology. But what is most important is the fact that this approach of having people at the center made processes that allow you see a couple of persons that are using the prosthesis really integrate these technology in their work. Another part of the work that we have been doing in recent years is with telemedicine and telerobotics. One of the motivation, of course, was the COVID. In the heat of the COVID first phase, people were isolated in hospitals. We worked with our medical doctors and with our ICT experts to build systems that could go and used to assist people that were isolated. So some of those were very simple technologies that could be deployed in care houses, and some of these were more high technology, like this small little humanoid that is being used in Cisanello in our hospital to talk to patients and to do simple operations. Next, please. The same idea of this telerobotics or teleexistence of robots can be used for assistance to people left at home, where you can, for instance, bring food or medicines, or simply tend to the pet, or open the door to the bell. And then, so let me now pass to our younger colleague Matteo Bianchi, who will close with something that gets closer to surgical robotics directly. Matteo, can you take over?
Hi. Yeah, I will try to do better than before. Yeah, well, as Professor Bicchi said, the sense of touch is very important and is extremely complex architecture, and our skin has many sensors and many receptors, and it is very difficult to model and even more difficult to reproduce with artificial interfaces, because this is a simple example. Without our tactile information from receptors, even the simplest action cannot be performed in a correct way. So what we did in Pisa, we proposed a model which is the tactile flow model that can take into account the tactile perception of object motion and also object compliance. And we demonstrated this model in psychophysical studies. And the goal was to use this model to produce artificial touch, which is important for endowing artificial hands with advanced tactile perceptual properties, or in telerobotics to give the user the feedback from the interaction with the environment, and of course in prosthetics, as Professor Bicky mentioned, and of course in surgical robotics. And what we tried to do was to build images for the hand, for example, using soft optical sensors and our model to compute the compliance of the object in closed form, but also to reproduce this information with interfaces. We all know a visual augmented reality where we can see real object and virtual object superimposed, but the challenge is to do the same in haptics, so to implement the feel through, so you can feel the real object and superimpose detail that are virtual. And this is what we did, for example, using this system, which we use for superimpose the artery pulse on artificial organs in open surgery training, in collaboration with Vincenzo Ferrari and Endotix, which is another center that we have in Pisa for research on planning, navigation, and simulation, but also for the training of surgeons using visual augmented reality. And still we use this system in collaboration with the group of Professor Simoncini and Dr. Giannini, for example, for rendering the information on the stiffness of myoma in telepalpation task. So this is only the first step, and we hope to continue in the future. Thank you very much.
Thank you, Antonio.
Grazie, Antonio.
Grazie a voi.
So we are moving in the next presentation. And it is my pleasure to introduce Ariana Menchaci, who is my good friend. She is a professor of biomedical robotics at Sant'Anna School and team leader of surgical robotics and allied technologies area at Biorobotics Institute. She is a coordinator of the PhD in biorobotics since 2018, and she was appointed in 2019 as vice rector at Scuola Sant'Anna. Her main research interests involve surgical robotics, microrobotics for biomedical applications, biomechatronic, artificial organs, smart and soft solution for biomedical devices. She is an associate editor for soft robotics, and she serves as associate editor of the IEE Trans on robotics from January 2021, and Ariana is a co-chair of the IEE Technical Committee on Surgical Robotics. Again, she is serving in the steering committee of ISMIT and received the WellTech Italian Award for her researches on endoscopic capsules. And she was awarded again by the Tuscany region with the Gonfalone d'Argento as one of the best 10 young talents of the region. Recently, she has been awarded again with the KUKA Innovation Award for her activities on robotic-assisted focused ultrasound. Please, Ariana. Ariana? Okay.
Hello, good afternoon to everybody. Thank you very much, Franca, for your introduction. And I'd like to thank the colleagues from Pisa University for this invitation to this event. Okay, thank you. I see my slide. So what I cannot see my slide anymore, but maybe they are on. Anyhow, I want to use this time frame to present a little bit of the story of our development of our robots, instrumented tool for surgery and endoscopy in the last 15 years, let's say. So we have a long story of development of endoscope. The main clinical idea from the beginning was to reduce the pain produced by the traditional endoscopic procedures. So to avoid that, the endoscope during the part in the colon deform so strongly the environment, and taking inspiration from simple animal forms, such as worms, to navigate inside the colon without any external forces, but by self-propulsion and self-traction. This is something that we developed along the years, also in collaboration with the clinicians of the Pisa University and the Pisa Hospital. And at the end of the story, something like 5-7 years ago, we developed also an endoscope that is now on the market, and it is called Endotix. It is moving by self-propulsion. Again, in the field of endoscopy, at a certain point, we tried to cut the tail of the endoscope, and we entered the field of wireless endoscopy, wireless colonoscopy, and capsule endoscopy. So starting from the year 2002, 2003, we developed a set of different capsules, about 2 cubic centimeters, with self-propulsion to be teleoperated in the gut. It was the time of given imaging. They developed a camera moving thanks to peristalsis along the gut. We tried to transform this camera with a sensor into a robot by putting some legs, motors, shape memory alloy actuators to obtain self-propulsion inside the gut. We faced major problems in terms of powering, and so we moved to the field of magnetic navigation. So as you can see in this movie, it was taken in Pisa, in the original in vivo animal center in San Piero Grado. We tried to use magnetic locomotion from outside to move a magnetic capsule inside the body. And this way we overcome major problems in powering. Next, please. Again, from endoscopy, in this case, to single port surgery. So we started to work on single port surgery, especially in the framework of a European project called Arachnes. This project was participated also by the Pisa University in the Endotix Center that was mentioned by Professor Bianchi. So in this case, the idea was, okay, I can enter the human body through a hole in the navel of about 25, 30 millimeter, and I have to deploy inside the body as many as possible degrees of freedom. So the final device that you can see here is a reconfigurable robot with 2 arms, 14 degrees of freedom, and the wrist and the elbow totally actuated inside with actuators on board. Just the shoulder actuators are located outside. And as you can see, the system is extremely compact. It was less than 5 kilograms in weight, with an endoscopic 3D camera located inside with the collaboration of stores. It was a very major project at the time. So you can see in the movie the introduction of the robot in the abdomen. Next, please. And we pushed the frontier of endoluminal and transluminal surgery also a little bit more by putting together our experience in capsule endoscopy, magnetic fields, and the idea of building up inside the abdomen a real surgical rooms. So we merged the technology that we developed for capsule endoscopy by producing small, let's say, module with the size of a capsule, able to reconfigure inside the body by using also an external magnetic traction, and able to do very simple tasks such as grasping or cutting tissue, but very inspiring also for additional studies on retraction and miniature robotics for single port and transluminal surgery. Next, please. And let's go to the first experience of collaboration with Intuitive Surgical. The first one was 10 years ago, let's say, and we participated in the research grant program 2013 with a project called the Suction Pool. So we are a team of roboticists, but mainly also by engineers. So the idea was to improve the retraction by using a combination of biocompatible bioadhesive polymeric films and a magnetic link between an external large magnet and an internal magnetic module. The idea was to obtain a stable and safe retraction system for several applications, but cholecystectomy as the first. This was the first attempt of a collaboration, successful collaboration with Intuitive. Next, please. And the second major result was when we received the DVR kit, the Davinci Research Kit. I have to say that we were the first group, we were the first group receiving the Davinci Research Kit in Europe. It was a major achievement, let's say, also from the bureaucratic viewpoint. Don't worry if the first movie, okay. So by using this Davinci Research Kit, for people not familiar with the system, this is a sort of skeleton of the Davinci donated by Davinci, and they use it for implementing new modality of controls, new tools, and so on. So we worked together with the Italian Institute of Technology to improve the part related to optics and ergonomics. And we tried also to combine the Davinci with the traditional rigid instrumentation with soft robotics. So as you can see in the last two movies, we combined the robot with a mobile camera that is actuated by pneumatic actuations, and that was able to give a sort of different, more, let's say, adaptable and more soft view of the environment thanks to this combination of different technologies. Next, please. We started also to work on simulators for, at the beginning, not for surgical training, but for, in collaboration with the Azienda Ospedaliera Universitaria Pisana, for training during intubation. And at this point, we started also our collaboration with Professor Melfi, with Franca. So together with Franca, we developed a sort of a simulator of a thorax for, with a diaphragm moving to, with a movable diaphragm, to do training for lung thoracoscopic surgery. And next, please. And again, with Franca, we started to think about how to improve the training, especially in some very specific tasks, such as the vessel isolation and vessel looping. So we developed a preliminary vessel simulator that is shown in the picture, and it is sensorized with special force sensor in order to estimate the force during grasping and looping. And we did some preliminary tests to understand if acoustic feedback is better or not of a visual feedback to estimating if the force is overcoming a certain threshold. As you can see, we developed a sort of bracelet, lighting bracelet for the Davinci. And when the force was overcoming a certain threshold defined by expert users, you see a lighting bracelet. So after this preliminary test that was done with not expert user, but students, we did the same task together with Franca in the robotic room. You can see some more expert tasks on the ligation of the vessel. And now, thanks to this activity, next please. We are starting now a new technology research grant with Intuitive. The name is a sensorized simulator for training robot-assisted lung lobectomy, and the short title is Operation 2.0. In this case, we are we want to to go in depth in the problem and to introduce our simulator, sensoritis simulator, with the different feedback during real training courses in order to make an estimation if there is a benefit in the final surgical practice by using our training add-on or not. Next, please. Okay, and the very last slide, what will we present here? As Frank mentioned at the beginning, I am together with Professor Vicky in Philadelphia for a conference on robotics, and in 1 hour, I think, we are going to present this paper that is a sort of milestone to celebrate the 10 years of the community of Davinci Research Kit. This was prepared by 2 PhD students from UCL and Scuola Sant'Anna, but both coming from Politecnico of Milano, just to mention what also Antonio was saying, that there is a vibrant community of surgical roboticists in Italy. And they have, together also with Intuitive Surgical, there is Simon Di Maio involved. Next, please. They have analyzed the literature of the last 10 years. The next, please. Of the last 10 years, and they have considered all the different data sets to see how the different data sets were used for shaping the research with Davinci Research Kit in the last 10 years. And maybe they can indicate also a trend for future evolution. As you can see, there is much attention towards training, automation, imaging, and vision. So that's all. I was quite short, but I tried to give a sort of overall vision of the collaboration with Frank and the University of Pisa and Storica.
Thank you, Gary. Thank you very much. Thank you, Antonio and Ariana. Thank you very much for participating. Do we have time for? No, we don't have time for questions. Okay. So thank you very, very much for your speech. You gave us a lot of suggestions also this morning, and I hope that University of Pisa and Intuitive can collaborate in the future. I will not be director anymore because I'm finishing 31st of October. Yes, my mandate is finishing, but I'm sure that anyone who will succeed me will, I would talk to him or her that this collaboration should be made effective, much more than it is right now, because it is already, but we want to do more and more. And I think that the theater project will be the right place to increase our collaboration. Thank you very, very much indeed.
Thank you.